All right, let's start with a basic idea. Not all derivatives move proportionally with the underlying asset. Some instruments are what we call nonlinear. So if a stock goes up 1%, the option doesn't necessarily go up 1%. Sometimes a small stock move causes only a tiny change in the option, and sometimes that same small move can create a huge change. Why? Because the relationship is curved, not straight. So even though we often use the delta normal method, we have to remember it's only an approximation here. Now, here's the problem. Delta-Normal VaR assumes a linear relationship. It assumes that if the underlying price changes, the portfolio value changes proportionally. That assumption works really well for stocks, bonds, and linear portfolios. But options are different. Their payoff is curved. So if we apply a linear VaR method to something nonlinear, our risk estimate can be inaccurate. In options, value depends on delta, and delta is not constant. It keeps changing. It changes when the price changes time passing and even when volatility changes. So over a long time horizon, delta moves around a lot, and linear VaR becomes unreliable. But over a very short horizon, like one day, delta barely changes. Thus, delta normal VaR works better only for very short periods. Okay, now let's look at the formula. The one-day delta normal VaR is VaR equals minus alpha times sigma times s times square root of t. Here, alpha is the z-score. For 95% confidence, that's 1.645. S is the price. Sigma is volatility. And T is time in years. Pretty straightforward. Now let's plug in some numbers to see how this actually works. Suppose the stock price is $100. Volatility is 25%, which is 0.25. We want 95% confidence, so alpha is 1.645. And since we're calculating a one-day VaR, time is 1 divided by 252 trading days. Now we just plug everything into the formula. So we calculate 1.645 times 100 times 0.25 times square root of 1 over 252. And that gives us approximately negative 2.59. So our one-day VaR is $2.59. This means the worst expected loss for one day is about $2.59. So if today the value is 100, the new value could fall to around 97.41. And with 95% confidence, we don't expect to lose more than this in a single day. So VaR basically gives us a risk boundary. It's not the exact loss, just a safety estimate. Delta normal VaR works well when the time horizon is short, like one day when price moves are small and when delta is stable. But it doesn't work well for long horizons, big price moves, or options near at the money where delta changes quickly. And when gamma is high, the curvature becomes strong and linear methods fail. So in those cases, we use better approaches like delta gamma VaR, full revaluation, or Monte Carlo simulation. So remember, delta normal is simple and fast, but only good when the portfolio behaves almost linearly.